Hey folks, we're just going to check out how to use a protractor today. We're going to look at a few things specifically in class numbers 77 and class number 80. So for starters, looking at class 77, you'll see here we have an incident light ray at about 25 degrees, and we have a reflected light ray, which we know due to the law of reflection will also be at 25 degrees. So let's measure these. So first thing you need is take your protractor, all right? You see this little circle here? That little circle there is always going to go on the vertex. Now, if I put my protractor like this, well, this isn't quite going to be right. I need to measure with respect to the normal line. So I need to turn my protractor so that this zero line here, this horizontal line that measures 0 here and 0 there, will be lined up with the normal. And if I look very carefully here, you can see that if I extend this line a little bit, let's see, 0, 10, 20, because I always start at the normal line and go over, 0, 10, 20, about 25 degrees there. All right, so this is 25 degrees, which it tells us in the problem. Now to measure this one, do the same thing. Put the little circle on the vertex, line up the 0 line with the normal. So you have 0, 10, 20, and about, this isn't drawn perfectly to scale because I made this on a computer, but it is about 25 degrees also. All right, as it should be. All right, so let's check out a Regents question with this one. All right, it says in the diagram below, a light ray is incident, let me move this down a little bit, on an interface between glass and air. When the light strikes the glass-air interface, some of the light is reflected. Okay, so we're going to look at the reflected light ray. All right, it says on the diagram, use a protractor and a straight edge to construct the reflected light ray. So the first thing you need to know is, well, what is that angle there? So again, you're always going to start by putting your little circle right on the vertex, okay? And we need to rotate it because, well, we need to turn it so that the 0 line, again, okay, 0, 0, so the 0 line is aligned with the normal. Notice here how our line does not reach here, so it's a little, we have to estimate it a little bit. Now you can use a straight edge to continue this line if you'd like, or you can kind of estimate it pretty well. It's about 40 degrees, okay? Now why isn't it 140? Because we always have to measure from the normal line. Okay, if I measure from the normal line, you'll notice I start at 0, 10, 20, 30, 40. All right, so this is 40 degrees. It's not 140, think about that. Like from the normal line, there's no way this is 140 degrees. Now we need to draw the reflected light ray, which is also going to be 40 degrees. So it's a little harder because you have to do it freehand. You're not just measuring an angle. So I know it's going to be reflected kind of this way here. Like I know it's going to come in this direction. All right, but let's be more exact than that. So let's put the little circle on the vertex, line up our 0 line with the normal, and find 40. So we have 0, or move this up a little so we can see it better. 0, 10, 20, 30, 40. Okay, so this is my point here that it's going to go to. Make that a little darker. Use my straight edge to draw an arrow to it. You can go a little bit past it. All right, and there we have it. So I didn't really even draw it going all the way to this point. I just use it as a guiding point to go to. All right, let's check out a slightly different one. All right, so this is from class number 80, this question at the bottom here. So we have a ray of light incident upon, it's in an unknown material incident upon an interface with air. Okay, so it passes into air. So this normal line doesn't exist. Material air is on the right. Material unknown is on the left. All right. So let's just confirm that this is about 30 degrees here. It might not fully be to scale, but that's all right. So if we measure this here, we put our little circle on the vertex and we put our 0 line along the normal. Okay, notice how our protractor is oriented differently now. And it looks like, yeah, it's about 30 degrees. Okay, 0, 10, 20, 30. Perfect. All right, so that is 30 degrees. So now we need to measure the refracted angle. Now realize that that is the angle between the normal and the refracted light ray. So it's this angle here we need. It's less than 90 for sure, probably more than 45. So just to give us an idea of what we need. So let's put our little circle on the vertex, line up our 0 line with the normal, and count for the normal. We have 0, 10, 20, 30, 40, 50, 60. So almost exactly 60 degrees. So this is 60 degrees here. All right, folks, and that's all there is to it.